Hi, and welcome to a WebRTC Fiddle of the Month. This time we're going to measure video codec performance. With me is Fippo, and we decided at least today that we're going to come with our corporate identity shirts. So let's start. Philip, to you.
Yes, let me share my screen as usual. So the fiddle this one is a bit larger because measuring is not as easy as the small things we usually do, but it's still less than 100 lines of JavaScript code. So HTML boilerplate is a bit bigger. We're including a graph library from the WebRTC samples, which comes from Chrome originally. We're going to paint a graph here. We are going to look at the resolution we get and what decoder implementation we get. Mm-hmm. And then similar to the last fiddle we had about determining which codecs we have a drop-down for selecting the actual codec to use without SDP munging.
Okay.
And then we have a start button and a call button. We also have some CSS this time. The canvas is going to be 800 pixels wide, which makes it nice and big.
Okay.
That is easy. We are combining two samples we have and basically putting the code from them together. So we're creating two peer connections, wiring up their own ICE candidate and ICE candidates. Calls.
So we're going to send the video from one peer connection to another.
Yes, we're not going to show the video on the screen this time. Mm-hmm. And we're going to draw a graph. And that is what we do here.
Okay.
We're going to use 720p at 30 frames per second, but you can also use other resolutions. And that's interesting to play with. Mm-hmm. So in the start button, we're going to get our capabilities. We're going to filter out the not really codecs like redundancy for video, ULP-FAC, and RTX. Mm-hmm. Because it doesn't make sense to select them because they're just like redundancy mechanisms, not codecs. And then we're going to add them to the dropdown we get. So let me show that. If we click start, the camera starts and we get a dropdown. Mm-hmm. VP8, 2 VP9 profiles, 4 H.264 variants, and AV1.
And we've got AV1 because you're using Chrome 90, the Canary version, right?
Yes, that got enabled recently. Mm-hmm. And the interesting question is, of course, how is the performance?
Okay. But let's continue.
Yes, then we're going to call get user media and add the track to the peer connection. Mm-hmm. Then once we click the call button, we take the preferred codec from the dropdown, for example, VP8, and we push it to
set codec preferences.
Yes, to the front of the codec list, and then use set codec preferences to actually enable it.
So we're not using SDP munging anymore, we're using actual APIs for that.
Yes. Yay. Which are not implemented in Firefox, I think, but Firefox, well, they need to fix that. And then we're calling set local description. Note that we're not calling create offer anymore because there's this implicit set local description. If you call it without any arguments, it will just try to figure out what you mean. Mm-hmm. Which is useful for small fiddles like this, because it saves you a line or two. Okay, so that's the easy part. Now, here comes the big part here, which is a periodic calling of stats.
The other easy part.
Yes, two easy parts. So we have a sender and receiver from the peer connection, and if they're not created yet, we don't do anything. Mm-hmm. And otherwise, we're querying the sender stats, store the last stats, and then do a comparison on the total encode time. And that is a difference between the current total encode time and the last total encode time.
So what we're trying to find out is how much time it takes us to decode a single frame.
Yes.
And then if you... Okay. And if you scroll down, you do the same for the decoder.
Yes. We always divide it by frames encoded or frames decoded.
Okay.
And then we're also looking at which decoder is used and what the resolution is. Because sometimes the resolution ramp up is slow, and that affects how much time you spend on the encoder or decoder.
Okay. Click the call button. This is what we're here for.
Yes. So we're doing a 3-second average, so it takes a bit.
Yes, it's a bit boring.
There it goes. And the initial values are a bit lower than what you get during the call, because it's still like it's ramping up from 320p to 720p.
And then we wait, and we see results.
And that is interesting because we get like 30.
Well, remember that we are on another call at the same time.
Yes, which probably means the other call is blocking our encoder.
Yes, and so we don't care about that, I guess.
Yes.
I think that the best way to do that now is, after we've seen that it's working and it's nice and we've got the graph, is to go and look at the graphs that you took earlier, the screenshots of them, and see what happens there.
Yes. So over to you.
Okay, so before we begin, this is a kind of a disclaimer that we're making, or EULA for this fiddle. What you did was, there are no bandwidth restrictions, so running with whatever it will want to use.
Yes.
We're running with 720p resolutions. You can play with that if you want. We're doing 30 frames per second. We're not doing simulcast. This is just peer-to-peer, and if we are going to do simulcast, the results are going to be different, right? Then it's Chrome Canary 90. My assumption is 91, 92, 93 are all going to improve performance a bit in each time, because performance of video is now the most important thing. And then you've used two machines. One of them was a Core i7 with 8 cores, a Linux machine, and the other one is a Windows machine with 6 cores. And the reason for using a Windows machine was?
Well, the hardware decoders work on that machine.
Okay. So let's go to the results. Okay, so this one is VP8, right? Encoders are going to be in red in all of them, and decoders in green. And the first thing that we see is that encoding time is higher than decoding, which makes a lot of sense.
Yes. Because the encoder has to make decisions about what to encode, how to encode, and the decoder just takes whatever it gets.
Yes. And the machine here is the Linux machine, 720p, and it uses a software decoder for VP8.
Yes, we can see that the decoder is given as libVPX by the statistics.
So for me, I'd say let's remember that for VP8, it's 4 and 2. 4 milliseconds for the encoder, 2 for the decoder. If we do the math, we've got probably around 30, 33 milliseconds of budget per frame if we want to do 30 frames per second. So 4 is a nice rounded number that is small enough for us to use. And just one thing, the fact that we've got 33 doesn't mean that we can use 33. It doesn't even mean that you can use 30 or even 25 or 20, because we need the extra CPU for other things of the machine. We don't want to overload it just with the encoder and decoder.
Yes, and sometimes you're decoding more than one video.
Or doing other things on the UI, or someone else is using the machine for other processes than your application.
Yes, also we have audio to take into consideration, and.
Yes. Okay, so that was VP8. And this one is VP9, profile 0.
Which is the most common profile.
And it's roughly the same numbers, 4 and 2.
Yes, the decoder seems to be a bit below 2 even, but that depends on the machine, really.
Yes, okay. But there isn't that much of a difference here for 720p at least.
Yes, the encoder is slightly more expensive. But I wouldn't say more than 10%. And the decoder is the same or better.
Okay. And then you switch to the Windows machine.
Yes.
And got results from hardware.
Yes. And you can see external decoders. This is a NVIDIA GPU. And you can see we're way below 1 milliseconds on average for decoding, which is much, much better than what we had before.
Why did you get me a VP8 one on Windows for a hardware decoder?
I didn't get a VP8 hardware decoder on Windows.
Okay, and that begs the question, is that because the Intel Core machine doesn't have the hardware for that? Or did Google just didn't do the optimization to use the hardware to the decoder for that?
Yes, there are some Kaby Lake processors which have VP8 hardware decoder, but it's not activated yet. There are some experiments, I think, but it's hard to find out what the current state of these things is. So you measure using statistics and look what results you get.
Okay. So then you try to play with other profiles for VP9, right?
Yes. Profile 2, which is a more, I think, more colorful profile. And I wouldn't use it for real time because we're going into 10 millisecond encode time and 3 to
2.5, I guess.
2.5, 3 milliseconds for decode.
Okay.
And
I guess this is why they use it for things like Stadia and cloud gaming, but not for video conferencing. Okay. But then you started playing with H.264.
Yes. And we see encoding in software 4 milliseconds, decoding 1 millisecond. And if we compare that to VP8, then we had 4 and 2, and now we have 4 and 1.
So the H.264 decoder, at least on this machine, was performing better.
Yes.
Okay. Interesting. And if we move to the hardware one on Windows?
Yeah, we get below 1 millisecond.
Yes. But the encoder seems almost the same. Not much difference there. You had another profile there on software?
Yes, it's a bit more higher quality profile, even though profile level IDs, nobody understands them really. And you can see it's roughly the same result. The quality might be a bit better, but it's hard to tell the difference.
Yes.
As a user.
And if you do that with hardware, you again get that half a millisecond or 1 millisecond for the decoder.
Below 1 millisecond, yes.
Okay. And now I think we're going to the most interesting one, and it's why we're using Canary here, Chrome 90.
Yes. So now we're looking at AV1, and you see 10 milliseconds for encode and 4 milliseconds for decode, roughly.
So the decoder of AV1 is roughly an encoder of any of the other codecs in terms of the performance, and the encoder is twice as more CPU consuming or even more than that. Okay.
Right.
Which is why this doesn't fit to some of the use cases out there today, at least.
Yes. And I mean, it's software. So for H.264, you have lots of hardware encoders. For VP9, you have some hardware decoders. So you compare the hardware results to this result.
I guess I would
4 times as expensive.
Yes. I guess I'd be fine with these numbers if the machine was smaller. Because at the end of the day, most people would have 2 4 cores today. At least on a desktop, and on a phone, it's just useless. Looking at these numbers and values, at least at this resolution.
Yeah. I mean, it would be interesting to run this experiment or this fiddle on a phone and see what you get.
Okay, so this is an exercise for everyone here that wants to play with it then.
Yes.
Okay, so you've got that fiddle now, people. Go use it and play with it and check it, based on the things that you're trying to achieve, or modify it to fit the application behavior that you have, so that you can make some educated decisions on which codecs you should start looking for moving forward in your application. Okay. So thank you for this one, Philip, and see you next month in our next fiddle.
Bye.